Doğan Hocam başlayabilirsin.
Sağ ol. Dear colleagues, good evening. Welcome to the webinar. The topic of the webinar is hot and very important, the future of laboratory medicine. The future of our profession has been discussed since the 1990s because new disruptive technologies in informatics, communications, and robotics disrupt or change some professions in medicine in general. Of course, laboratory medicine is also affected by these technologies, especially by digital technologies. So, unavoidably, there are uncertainties and concern about the future of laboratory medicine. Our speaker today is Professor Tomas Zima from the Czech Republic. I would like to introduce him shortly. Professor Zima graduated with honors from the Faculty of Medicine of Charles University, Prague in 1990. He completed his doctorate in biochemistry at the same institution in 1993. He became president of the Institute of Medical Chemistry and Laboratory Diagnostics in 1999. He became a specialist at the same institution in the year of 2000. He became a professor of medical chemistry and biochemistry in 2001. Additionally, he completed his master's degree in business administration in 2003. He was Dean of Charles University Faculty of Medicine between 2005 and 2012 and Vice Dean after that for 2 years. He was Director of Charles University between 2014 and 2022. Professor Zima is a specialist of clinical chemistry and he holds European Clinical Chemistry and Laboratory Medicine Specialist Certification. He continues his studies in the field of laboratory medicine at the national and international level. He has given hundreds of national and international lectures academically. His publications include 8 books, 71 book chapters. There are over 300 scientific papers in Web of Science. There are more than 5,000 citations to these publications. His H index is 37. He has served and continues to do much work at IFCC and EFLM. I have known him since the preliminary works of the 2014 World Club Congress. We made this Congress in Istanbul, you know. He made great contributions to the Congress. Currently, he is a member of IFCC Education and Management Division, and he is EFLM Executive Board member as elected president, and he will begin his term as president in January 2026. Professor Zima is in our country now, in Izmir, now as the guest of Professor Gülgüner Akdoğan. With his scientific and administrative knowledge, he will enlighten us about the future of laboratory medicine. He will also come to the joint congress of BCLF, Balkan Clinic Laboratory Medicine Laboratory Federation, and Turkish Biochemical Society, our society, in the end of October this year. We thank him very much. And Professor Zima, screen is yours, please, now.
Dear Dogan, thank you very much for your kind words. We know, and I have many friends in Turkey. Now it's not welcoming from Prague, but I am sitting in Gil House in near Izmir, and we have also the nice meeting with Ferhan, and I have the many friends in, and it's the Congress which I supporting the group from Turkish society. It's in Istanbul. It will be grateful, and I believe that the PEPS Congress next year in Istanbul and other activities will be fruitful. And I have the many friends. As mentioned, the EFLM. The Tom Risosben was the past president of EFLM, and now with the IFCC president. And I have the many friends here, and thank you very much for kind words, and thank you also for a kind invitation to your Congress in end of October this year, and now for the webinar. We discussing and select the trends in laboratory medicine, and yeah. But if you will go to history, our NFI in the Aegean area, we must decide that some laboratory test is done, or chemical test or chemical examination was done also 2,000-3,000 years ago. But if we will go to the history of such as the blood clotting, it's from the 18th century. Sweetness of urine and blood, it's given by sugars in 1776. Some experiments and some development of the bacteria and microbes, it's 18th century. And in 19th century, first labs should be developed. And if we said the first laboratory appears in St. Guy St. Thomas Hospital in London in the end of the 19th century. Our profession as laboratory medicine or clinical biochemistry, it's around a 120, 130 years old profession, and its first textbook is published in 1899. If looking to the labs 100 ago in US, it will be in the modern hospital at the time, scales, microscope, centrifuge, Bunsen burner, colorimeter, and it's done. If looking to the 1970, the lab is a little bit moving, but not so much. It's spectrophotometers, phase photometers, fan-stack apparatus, centrifuge. But the great development of our professional laboratory medicine is in 80s and 90s with the automation in the spectrophotometry. It's automates, and also when the immunochemistry assays is coming. There is a little bit old equipment, and now if you're looking to the picture of the lab, some equipment from different company to joining together or be separately is growing up with a wide with a high speed capacity around thousands tests per hour. Also in immunochemical tests, not only the simple photometric assays. Laboratory medicine, it's a very important and integral part of the medical processes, from prevention. If you're looking for, as example, for screening of the diabetes or screening of the colorectal cancer, the occult fetal blood tests, diagnostics, it's clear, monitoring of the therapy by the different instruments, and also the pharmacogenomics, and it's including to help patient care management, and it's also provided the high quality, safe, effective care to the patient. We know that it's some 70%, which was published by Michael Harvard 13 years ago, that it's 70% of medical decisions and diagnosis depends on our results, and also it is some majority of the information in the medical records. It's true because many diseases is based on the description of laboratory tests, heart attack, diabetes, hypercholesterolemia, atherosclerosis, etc., etc. And what the main trends in laboratory medicine now? The one way, it is a total laboratory automation, joining the disciplines, and it's many labs put together in some chains in the regions or international level. It is connecting the discipline and technology, because if you have the immunochemical reactions, it should be used for tumor markers testing, testing for viral bacterial diseases, monitoring of the drugs, and so on. And it is the technology which should be used. Now it's coming the artificial intelligence in our profession. The lab is put together to the change to be more effective. Some also the shortage of health professionals, it's everywhere, is done. Growing up the near patient testing or POCT, not only in the ward, in the hospitals, in the GPs or specialist ambulances, but also for testing at home. And new technologies as digital hematology, MALDI-TOF, mass spec is be more common in the lab and not only in the central or university labs in the countries. What's people in now it's more more looking for the prevention and monitoring of the disease, and the biomonitoring it is main topics for the near future. Of course, the nanotechnology chips or lab on the chips, it's a very promising, and omics from widespread from epigenomics, proteomics, metabolomics, and so on. Molecular diagnostic techniques, NGN sequencing, microarrays is growing up, and new tools as a mobile medicine or telemedicine or different equipment should be used. As example, our webinar today, it's also the telemedicine, or if there is some patient, we should discuss the health problem and so on. And we have many data. We are maybe the overlap of the data, and it is integrated for different disciplines. What we are working in EFLM, it is also integrated with the imaging data for comparing the diagnostic and monitoring diseases for the patients. We have also some risk on it. We have the new technologies, but also the limited budget. The number of tests, it's widely increasing, but now in EU, we have the IVDR directive. It will be very strict for testing of tests, and we know that some companies will be cutting off the tests for the European market because not effective for them to go through this regulation. There is also the many testing, unnecessary testing, which is sometimes the alibism of the physician doing the test. I told you the one smiling story. Maybe 10 years ago, a friend of mine, which is very carefully looking for his health, asking me if I should do all tests in my department. I said, I do it, but you not have enough blood in your body. Yeah, and it's done repeatedly tests, and which is not have the information. And also we have the limits of the results. One part, it's laboratory automation. It's a quality, reliability needed for laboratories, and it's also for personalized medicine. We discussed the integration as a one process in total laboratory automation. It's coming from centrifugation, aliquoting to archiving. And the other process is consolidation, because the equipment from the IVD companies, it doesn't matter if the photometric assay, if it's a nephelometric test, immunochemistry test, it's measured the proteins, enzymes, if measured some antigens from virus, if measured the allergens, etc., etc. And we should put together all measurements, including the hematology for coagulation and for the digital morphology part. And now it's also integrated the microbiology, immunology, and immunochemistry. And it's a process of consolidation, which is very effective for the throughput between the equipment. And this total laboratory automation is coming and including the pre-analysis to post-analysis part with the whole report results. And the technician should be used to all technologies, and final results, it should be divided to the healthcare professional or MDs in immunology, hematology, biochemistry, molecular biology. The benefits, as I mentioned, it is a reduction of the cost, manual work, of course, and also increasing the quality and reduction of the errors in the lab and a high level of accuracy. And it's also, we don't forget the ethical dimension, because sometimes we sending the samples of blood to 5 labs. The lab is needed 200 microliters of the sample, and other blood is go to waste. It's very carefully in the patient intensive care unit, and some paper published that around 30–40% of the patients which are stay on intensive care unit more than 1 week have anemia due to the blood sampling. It's safer, increasing the efficiency of the results, and also for the rerun and reflective testing. There is some theoretical, I not like to make some company line, how it's due the total laboratory automation from hematology, immunochemistry, urine, centrifuge, storage management, microbiology also, which will be joined together. It should be done by one company. It's done, excluding the microbiology, but mostly we use the equipment, and majority will be from one company, and other equipments, for example, Dynex for some immunochemical assays, and protein assay maybe from Beckman Coulter, and it's connected by the Impeco Prague from Italy, or now it's one German company which is not well known, starting also the connectivity between the equipment of the different companies. There is the other model how it's work together, from urinalysis, hemostasis, allergy, measurement of glycated hemoglobin, from centrifugation to the storage line. If we go from whole laboratory medicine, the microbiology is many decades. It's only the labs and waiting for 2–3 days results, but also in microbiology is coming the automation and the molecular diagnostics. It's widely known in the whole society after the COVID, and million of people are expert on PCR measurement due to COVID's epidemic, and multitude of technologies. There are two total automation system in microbiology. One from BD Kiestra and Waspan, a lab from Kopan company. It looks like here. It's put together the incubation, plate sorter, inoculation part, photography of scanning incubator, and also digital display system. It's around the world about now. It's 70 system. It's very expensive, but it's do precise results. It's maybe for the big region, and most of the private network laboratories network chains have this automated system, which is also looking for the multi-resistant organism, 24-hour service. There you not should wait. There is a staff, but also there are some berries because some different investigation species which is not make a result by the digital scanning. Sometimes it's a problem with collection of the materials and samples, and then they, of course, the human cannot be replaced on this automated process, and it's a promising, and it will be growing up. There is also the picture of the incubator of the Kiestra from plate tracks. fully automated process. It needs a huge amount of the place. The Moderator, it's widely used, maybe 15 years. It's very potential, make a shortage for the finding the bacteria and microbi. There are the two main companies for this mass spec analysis. There is a type of the analysis of the protein. There is, for example, the Escherichia coli, which is as a one example, and working with the libraries to describing the microbes. What the problem, and it's not yet fully sorted out, it is the and antibiotics resistance, that it's also needs some classical tests, but now it's looking for some changes in the characterization. If some bacteria, it should be a little bit connected to some group resistance, antibiotics resistance, but for a resistance using the classical test. There are some examples of the molecular diagnosis of infection. If you're looking for the PCR cycles, what are the main problem in the PCR for PCR of a COVID? Well, that the many labs which not are expertise in PCR, waiting for cycle 60, 70, which is something done, but it is not a true result, because it's up to around 40 cycles will be in COVID, and no more if it's not make replications. The other part, which is digital morphology, it's better be said, because the digital morphology should be used for the cerebrospinal fluid analysis, and also for the description of bacteria, viruses in a specific microscopic, specific electron microscopy, or for parasites. But it's widely spread in hematology, which should be used also for cell counting and flow cytometry. And there is one example how it's computer selecting the different cells, and they also should be supervised by the physician, and take one cell selectively and looking if something works, and it's using for the first step, and finally for the precise characterization of the cells, it's using the flow cytometry. There is the example of the red blood cells, and it's helmet cell, sickle cells, spherocytes. So it will be also describing in the cell sample. Using the one picture about the nádor utca, because nádor in Hungarian language, it's same as in Czech. Sorry, I don't know how it said the tumor in Turkish. And tumors, it's well, now the test the classical tumor markers, which growing from the 60s, 70s as markers for monitoring mostly. But at that era, maybe 2 decades, it's mostly area for the molecular diagnostics. And we use all kinds of techniques, from single gene analysis, some mutations which will be connected to the risk of cancer, several genes classification, and finally NGS sequencing, which is very growing up for the describing the tumor. Example for single gene analysis, it is a BRCA1 or BRCA2 mutations. It's a family breast cancers, and also sometimes in which is increasing, and ovarian cancers. There are some description of the sporadic mutation, and there is the BRCA mutations. It's a very high predisposition of the breast cancer, and this women which are Bursa A mutation have in this is the genes, it should be precisely screened because the risk of the cancers is extremely high. Multigene arrays, it's combine some expressed and repressed genes in tumor and make some map or picture of the tumor. It's not using an hematology marker, hematology tumors, but it's also the addition, and it's maybe more colorful picture, not as the green and red, but most colorful about the metabolism, proliferations, and interaction also with epithelial cells, which is important for the way of the treatment of the cancer as example. But NGS, it is a revolution in laboratory diagnostics, not only in tumors but also in the pulmonary hypertension, in inborn errors of metabolism, in some risk of the cardiomyopathies, etc. It's starting 24 years ago. There are some story and type of the companies which growing. Maybe the Illumina, it is a leading one, which producing the wide portfolio from different sequenators, from the small ones, mini-seq to next-seq to NovaSeq, which is increasing the number of the sequencing of exons and also should be an introns, and price cost is growing down during the history. There is it's typical example for personalized medicine, the NGS, because it's a analysis of the individual genetic variants, as I mentioned, from oncology through hepatology, immunology, gastroenterology, neurology, nephrology, ophthalmology. It's widely spread in human medicine. And there is some scheme from extraction, libraries, amplification, sequencing, mapping, identifications on variants, and bioinformatics. It's very important, and the variability, if it's a germline, somatic, epigenetic, non-invasive prenatal testing, cell-free DNA, for example, for liquid biopsy, metagenomics. It's widely spread and widely useful technology in the laboratory medicine. As I mentioned, the liquid biopsy, it's also very promising technology, which is growing up for a personalized treatment, because it's mostly in relapse of the disease. We are not have the possibility in majority of the cases to take tissue samples for the metastatic process, and but we should use this liquid biopsy for cell-free DNA from the tumors. It's very good for monitoring of tumor changes and also for the looking for a resistance of the treatment. It's one part that we're looking for the cell-free DNA, but we're also looking for circulating tumor cells which are heterogeneous. There is also the matrix and the carcinogenic cells which should be selected. What the advantages and disadvantages between the classical tissue biopsy and the liquid biopsy? Advantages of the classical way, it's validated. We have a tissue histology. We should take off the proteins, RNA, and it's clear. Disadvantages: invasive, cannot be often repeated, and sometimes it's not represent part of the tumors. Advantage of the liquid biopsy, it is a minimal invasive, taking 10 or 15 milliliters of blood very rapidly. represent the heterogeneity of the tumor. And also it's possible if it's a tumor it's in poor availability of the tumor for taking the samples. And what's the most important, it is a real-time monitoring the therapy. Real-time. We should make every month, every 3 months, a monitor the tumor and progress. Problematic, it is stability, not clinically validated in some cases, and non-DNA markers cannot be removed. Now, if you're looking for the what's done in the vessels from health tissue, tumor tissue, there is a mixture of all, and we are also taking the exosome microvessels, free circulating DNA, circulating tumor DNA, cells, and so on, and it's problematic. And this circulating tumor cells are from metastatic cascade as one. It's also for tumor disseminations and tumor progression with epithelial mesenchymal transition. If we will exclude the blood, as I mentioned, but we make a liquid biopsy from cerebrospinal fluid in the brain tumors, metastatic brain lesions, saliva from head, neck, and lung cancers, pancreas, breast, ovarian fluid, cystic fluids, urine for bladder, renal, and prostate cancer, and also from the bone marrow parts. It's widely spread, and liquid biopsy should be used not only for the blood. We using the liquid biopsy should be in cancer screening, but it's not done yet. But mostly monitor the risk of dissemination, and maybe mostly for the monitoring of treatment and monitoring the response. We selected and amplified the DNA, and also we should cultivate the circulating tumor cell and multiply DNA. Now if we are looking for some different modalities and biomarkers which corresponding to solid tumors, there are some markers which be using by different technologies, by the sequencing, by the fragment analysis, qPCR arrays, and this biomarkers is characterized from different tumors in the human body, and with this technique we are precisely describe which marker is overexpressed or downexpressed in the human body. And it's connected also to therapeutic target and resistant mechanism through to the circulating tumor cells or circulating tumor DNA. And there is a different type of molecules with connecting to taxane resistance, anti-GRF therapy in non-small lung carcinoma, EGFR therapy or colorectal carcinoma, and other markers which would be, which should be fine. And the liquid biopsy is very effective for looking and monitoring the effectiveness of the treatment through the genome analysis or transcript protein analysis. When we look for the whole analysis of the tumor and clinical examination, as example in the lung cancer, there we have the imaging, tissue biopsy, antigen detections, liquid biopsy, including the microRNA, circulating RNA, circulating tumor DNA, exosome, and circulating tumor cells. All together, when we have the real picture of the tumor, and also comparing with the personalized treatment of the tumor, and go go together and monitor the disease. Exosomes, it should be very good next generation diagnostic and therapeutic tools for the looking. There are some exosomes here which is secreted. It is a process in the cell, and from exosome we should make the analysis about the invasion, multi-drug resistance, tumor immune escape, angiogenesis, and EMT. And this exosomes, it should be effective for the studying and monitoring the tumor disease, lung to cancer disease, for the both sides, for diagnostics and monitor the therapy. And there is many modalities which will be done, different genomics techniques, epigenomics technique, because the methylation patterns, it's very important, transcriptomics, gene expression, fusion, cell type composition, proteomics, profiles of the tumor, metabolomics detection, and this leads to the precision oncology, personalized treatment to each patient. And it's team of the experts, imaging, proteomics, genomics, histology, and it's team put to the best for the patient, and it's playing role our most techniques together. And some of you know that few years ago we are putting together activities with the Radiology Society to make a complex view for the not only the tumors but all combining the medical imaging with laboratory medicine. The other part, as I mentioned, it is a proteins. The human genome is describing. We have the mRNA splicing forms, proteins. It's very tightly connected. It's known in the gymnasium and in the medical schools. But there is a specific size of each. There is a glycosylation, phosphorylation, acetylation, fatty acid acetylation, the post-translation modification, which needs to the huge amount of the proteoform which is in the human body, which should be affected the disease and the treatment. And now we look for the proteomic analysis of the tumors. I make the one example of luminal carcinoma of kidney. That there is if you are comparing the patients and the health patients or health control, we take a tumor plasma urine, extracted mass spec, and functional analysis of tissue, serum, and urine together, make some map of the integration of the data. And if you will integrate in, you will find the common proteins which fall higher than 1.5, and it is total number only 21. Oh, sorry. There is a urine 2100, plasma overlapping around less than 700, but 21 are these proteins maybe fall about 1.5. And this is describing the proteins. There is a map of this molecules, which is some protein class from cytoskeletal adhesion, transportation molecule, and if it's a function, if it's for binding or catalytic activity. And we are describing the molecules, the proteins which are changed, which are being increased or decreased, and interleukin 15 signaling, complement system, B cells, receptor signaling, etc., etc. And finally, we make some data of the cases, plasma and urine, and you will see what happens in plasma and urine with selective molecules. In the health, there is nothing, only rare, but what it's clear in the patient, and there is this standard ROC curve, and we're looking for the molecules which should be used for the possible biomarkers of this tumor, mostly for monitoring of the disease. I mentioned that the telemedicine, digitalization, mobile health sensors is growing up at that time. The telemedicine was the great example, the communication of physician with the patient during the COVID pandemic. But I think that it's very helpful for the communication of course, outside of the pandemic. There are some example how it's done. It is the telemetry, digital patient, robotization of care, using the artificial intelligence, sharing the data, and also the assistance in some cases. We have one project in the region in the Czech Republic, where is the connectivity of the senior house with the hospital for communication with the staff and the patient. If it's should go the emergency services to the senior house, or if it's go to the regular services, or if it's waiting for tomorrow or day after tomorrow for services, and they should manage some situations. Well, now there's a monitor glucose monitoring. If there are some examples, the glucose watches, different, but also the smart contact lens with the microchip, which is done, and some implantation for the monitoring in the diabetic patient, mostly in diabetic mellitus, patient with diabetes mellitus type 1. We should say that there are some skin on the lab. There are some different chips should be put on the skin which detect some parameters as ECG, temperature, but measured some basic parameters, ions, glucose, lactate, oxygenation, hydration, skin modulus, and it's widespread and dramatically developing. We're working with one company not for a skin, but for the lab on the credit cards. There will be put the drop of the blood, and it's passing through the different electrodes and technologies, which measured approximately 20 laboratory parameters. Other is a non-invasive methods which measuring some parameters. We're also working with this company to do it. There is many parameters which is done and measured by the principal. At the beginning, because I am very I waiting for results and computing. At that first time when the person from this company coming to my office and said me, we are testing with in America, in Israel, in Germany, this equipment with the plethysmography. We measured these parameters, glycated hemoglobin, cholesterol, and others. I said, okay, measured for me, and I will look to my laboratory information data. And the glycated hemoglobin by this plethysmography shows 38, and in lab in my medical record was 39 by the HPLC. And after I said, okay, we will testing this plethysmography, which should measure some parameters for I mentioned for the monitoring of the patient at home with connectivity with the GPs or other physician, and it's many people now are looking for the healthcare and to be health and make some preventive medicine. Now we are era of the artificial intelligence, which should be helpful to comparing the big data from imaging, big data about the endoscopic biochemistry, and also the genome analysis, it should be used this application of artificial intelligence, and we will see in near future what will be happens in different area and how it's moved in medicine totally, not only in the laboratory medicine. There are that some automatic will be done. There is a picture of me in Rome Congress, World Lab, Euromed Lab, the last May, and there is presented the automate for a blood sampling. We will see how it be effective in the future, but the automation, due to the lack of the professionals, is growing up, and also in Rome was presented the automated laboratory which working with low staff or 1 to 2 person which working with the equipment. It's and also shows us on the pictures at the beginning, if you have the total automated labs, there are need less technicians around the sampling, and the data for the approving the results and for the make a decision from the digital hematology, it should be maybe on a different continent. It's done in the imaging. There are some centers which in India where people reading, the MDs reading the CT scan, mRNA from different areas in the world, and it's now due to the technology, it should be sending out, and this total laboratory automation with technicians should be in Izmir, and the expert for hematology will be in Vienna, expert for immunochemistry will be in Istanbul, expert for coagulation will be in Ankara, and this online decision should be done and confirmed. Also, the topic about the smart labs, it's integrated the machine learning, IT standards, but also coming the drones, mostly for the transport of the samples, maybe in the big cities. It's where is the huge traffic. It should be transported. It's now it's a discussion in some countries how it's transport the samples on some safety level. And data analysis, security of data, it will be also ahead in front of us. When we go what the lab will be the future, I think it will be the redesign, the structure of the labs will be in the region, one core labs in the region or in the big city, with the satellite labs in hospitals, outpatient clinics, and a widely spread POCT system from GPs to emergency services, intensive care units, high level of automation and consolidation of the laboratory subject by technologies. But finally, the results will be make the comments and reporting by the MDs with a different profession or non-MDs with a certification in laboratory medicine. Molecular diagnostics will be going through not mostly in oncology, but it's widely spread in cardiology, gastroenterology, neurology. We're most looking for the microarrays, liquid biopsy, telemedicine, mobile health, e-health will be definitely growing up through the young generations. We must be prepared to working with the big data, with biomonitoring, with the bioinformatics. We will see what will be the artificial intelligence and expert system well done, because I worried about one issue. This system is counted. Some GGT is mostly increased in biliary diseases, but stones of gallbladder. But in some cases, it is in border of fetale embolism or very rare disease. And how it's we sorted out these rare diseases or not so frequently findings in the laboratory markers. And if it's counted by the 90% to 0.001 case, but every patient is, or every man is unique. Multitoph and mass specs will be growing more directly to the routine. Also in Ward Lab in Rome, it's showing the two automate for the mass spec by two companies, Roche and Shimadzu. Micro technologies, it's all around. Omics, we will see how we work. I am a little bit, I mentioned that it will be more precise in specific cases because we know some, or most of you, that 20, 30 years ago was a huge revolution about the proteomics. We have the proteomics data and all is over. 20 years gone and not so many changes in the daily life. So definitely there will be not press, but importances for integrated diagnostics, laboratories, imaging, endoscopic data, and other data put together, with also using the expert system and computering, because the computering and machine learning, it's find anything on the screen and not too tired, as some physicians maybe after 7 hours working, these computers are not have a tiring. And it's very important, it's a high educated staff in different disciplines, not only the profession in the laboratory medicine disciplines, but we will need the lab technologies, IT tech experts, physicists, and also laboratory medicine is widely spread in some also person with economic backgrounds and so on. And finally, from the lab, maybe from the 18th century, with some maybe the colorful reaction of the urine in diabetic patients, we moving to the molecular diagnostics, proteomics or omics, to predictive also disease. And there is what's maybe some smartphone holder with smartphone, and which is doing some labs, not on the chip, but labs on the smartphone. But we will see in the future what's we done. Thank you very much for kind attention. I am open the question and teşekkür ederim.
Dear Tomas, thank you very much for this nice and informative presentation. I think those new technologies you mentioned will profoundly affect our profession and change it, I think. But I don't know, disrupt totally our profession or not, I don't know. And now take the questions. Kamil Taha Uçar, a young specialist colleague from Turkey. Dear Professor Zima, thank you your inspiring presentation. What are your thoughts on large central laboratories? In your presentation, you mentioned the many advantages of total laboratory automation. However, I believe that such large laboratories may lead to an increase in test requests. As we speed up the testing process, clinic demand will likely rise. Naturally, this will increase the workload. What is your opinion on this matter?
Yeah, it is. I will look for the questions here. I think it's barrier how it's put. I will look for the question here. It's central labs. I think what will be very effective, and we will see if it's done. As example, large laboratories have a huge amount of the sample. It's more effective. As I said, if I am now in Izmir or I was in Istanbul, in this area, it should be 2 huge big labs for 1 million or 2 million people. But these labs, it should be connected to the small hospitals or hospitals around where will be the satellite labs, which providing the spectrum of 50 tests or 100 tests, and finally POCT, but it will be unified to the one platform or maybe sharing the data. It's we doing in one region in Czech Republic. It is a region about 1 million of people. There is a system of the hospital. There is a big one hospital in the regional city, and 7 small hospitals in the regional city in the other cities. And there is have a same equipment, sending the labs and count it. If you have per year less than 300 tests, it's close it, put sending to the central labs, because it's really effective, and the report will be next day or afternoon. When I starting the centralization in our hospital, we have in our one university hospital in 1999, we have 10 labs which measured TSH. The response was 2 hours up to 3 weeks in one hospital. And of course, the labs, if we will increasing the test, it must be some regulations, because as example, in our country, the health insurance company makes some blocking, and the labs should add some laboratory tests. And it's maybe there's a barrier that the big labs not increasing the sample, but because it's not be paid, yeah. And if I know that it's paid by the insurance company, it will be not asking, yeah. We have this period in our country, and then at the beginning of the century, that physician put the cholesterol and lab said it. LDL, HDL, ApoA1, ApoB, and adding. But the health insurance company said, no, it's paid by the lab. And it is, I think, the blocking to increasing the laboratory test. But if you have the lab that is doing approximately daily testing from 10,000 people, it's you not asking to adding the sample, adding the test, yeah. And of course, the workload is very effective, and it's huge private labs in Europe have this core labs which are very, very effective and working.
Thank you. And another question by from Muhittin Serdar, Professor Muhittin Serdar from the Acıbadem University. He has 2 questions. One question, how will the new IVD regulations affect laboratories? Does the EFLM have any opinions and studies on this subject? And 2, thank you very much. Many laboratories use in-house methods for special tests, especially mass spectrometric, chromatographic, and ICP-MS tests, as well as special enzyme assays for groups such as lysosomal enzymes, etc. How will new IVD regulations affect the in-house tests that laboratories develop and validate themselves in the coming years?
Thank you for the great question. It is. We go to the devil's way. It's very crazy. It's breaking most of the tests in Europe in laboratory medicine. this new directive, you know how it's starting, this directive? I will set you the story. In Germany, many labs in transfusion medicine make homemade PCR tests, but very effective, homemade PCR tests. And the company said, no, it's not good. We like to make a business in transfusion medicine with the PCR test and testing for HIV and hepatitis. And go to Brussels and said, we need a regulation which will be safe and protecting the patient and society. And this is the beginning of this new IVD regulation. It's new IVD regulation, it's 6 years old, and all is postponed the dates. Last dates for implementation is 2031. 2031. Yeah, you hear well. Because if it started, nobody knows by the experts in Brussels. That is unbelievable job, which very costly. And I think that not so increasing the quality and safety of the patient. I discussed with many people in Brussels and around this, and I asking, okay, this regulation is too strict, go back, change the regulation immediately. I receive from one very skillful and well-known Brussels officers on that topic, and he told me, Thomas, Brussels is not make mistake. We should implement, we should maybe better regulation, which will be changed, but we not make mistakes. It's done. We will postpone it or make some news and maybe more smooth, which will be waiting 5-10 years and so on. EFLM is very hardly working on these discussions after the IVD regulation. We are not involved at the beginning of this crazy topic. We are working together with the Biomed Alliance. It is the umbrella of more than 35 European medical associations because it's risky for the European market. And I know that some companies, they make a decision that they not go through this new IVD directive, and the European market will be excluded for the, it should be only used for the research. In-house methods, it's very problematic, and you should make some protocols that you are go according for safety and according the quality regulation as IVD regulations needs, but it's a huge amount of it. In our society, we're discussing, we have some experts from private companies, we discussing with our regulatory institute. It's called the State Institute for the Drugs and Treatment. There are no experts on it. These guys coming to my department to learn what is its test, what is its substance, what is its product, because all of these 5 people have the chemistry at least 20-30 years ago in the secondary school, in the lab in secondary school. And it will be huge paperwork without any effect. And in-house methods is comparing. You have the test for cortisol with the IVDR regulations. We have the approved for serum, but you should like to measure cortisol in urine. No, you must go to the paperwork that it's safe, etc., etc. It's a very I not mention as you asking chromatography, ICP-MS, but molecular diagnosis, classical PCR test, what it's done. Yeah, not only the lysosomal enzyme, but all it's done. It's crazy, and I believe that now it's postponed to 2731. I believe that it will be postponing to the end of Earth, maybe 3000, etc., etc. Or I believe that will be the working on new IVD directions, which will be more better and more realistic than this crazy regulation.
Thank you. Another question from Hikmetcan Çubukçu, a young specialist colleagues from Turkey. In Czech Republic, can the laboratory medicine specialists deal with all kinds of testing panels, including microbiology, molecular diagnosis, genomics, metabolomics, proteomics?
Yeah, in Czech Republics, we not have according by as a medical discipline as a laboratory. We have the clinical biochemistry, hematology, microbiology, immunology, genetics as a MDs. For non-MDs, there is a laboratory specialists, including majority of disciplines, but as a basement. But finally, you should specialize to microbiology, genomics, and so on. Metabolic proteomics, it's only in few university departments, and there is more experts from the University of Chemical Technology or Faculty of Nature Sciences, which are not experts or not qualified in medicine, but qualified on the technology. We, as in most European countries, MDs are specialists in the different disciplines, as same as UMS recommendations, and the non-MDs are more widely spread for laboratory medicine with a second level of exams to be specialized in microbiology or hematology, etc.
Thank you. Another question from Muhammed from Norway, a Turkish specialist. Dear Zima, thank you for this great presentation. You mentioned various improvements for medical laboratories and their future implications. What do you think about connecting disciplines? Could it be applicable? Best regards.
Yeah, I think it's applicable. In the United States, there is a clinical pathologist, and it's work. But I think in Europe and here, there will be two levels. One level, it is analytic processes, spectrometry, immunochemistry, digital imaging, chromatography, NGS. And for these technologies, you are not should be specialized. If you are expert on immunochemistry, it doesn't matter if you are measuring the tumor markers, hormone, viral, antibodies, allergy panel, etc., etc. I think that for a technological part, it mostly joined together. Finally, about the medical disciplines or looking for the connectivity, there it should be the expert on different branches. I like if the people will be more connected, but in some disciplines as hematologists have a part-time in ambulances, part-time in labs. For clinical chemistry in our country, we have also possibility to make ambulances, but it's minority of the practice, as example, 10-20%. Yeah. But for the analytical or technological part, it's definitely will be connecting. And for the professions, I think that in the future, due to the lack of professionals, maybe the expert on the laboratory medicine on the basement, which you do, and you have the specialized in chemistry, in allergology, in hematology, because as the MD is looking for the blood cell count or coagulation cascade, I have a knowledge if there is anemia or if it is anemia due to lack of some vitamins. I need to integrate the data as a physician. It should be done, and for some specialty, it will be more professions in MDs. But for non-MDs, I think it will be more connecting.
Thank you. Another question from Muhittin Serdar. What kind of future awaits medical biochemistry education? How will we prepare our education for the future?
It's very, very good questions. I think the medical biochemistry education will be widely spread in universities, which will be in 2-3 classical packages. One, it is the metabolism and the metabolic parts for the Krebs cycle, glycolysis, etc., etc. Second part, it will be the molecular genetics and molecular medicine, and third part, it will be the biochemistry of the organs, on organ biochemistry and connecting to the disease. It should be done, and it depends if it's 1 year, 2 terms, or 3 terms. It depends on the history of the country's education. And how it we prepare? Yeah, we must be prepared for future. What's important? It's need the very hard basement, very hard basement. When I am studied in the medicine, I studied with 1984 up to 1990. Medical biochemistry I have in the second year. It was in 85 to 86. About the molecular biology, we have 5 lectures, not practical lessons, and not exist the PCR and other. But if you have the principles of something, you educate whole life. Yeah, it's same as this with the computer. At the time, we not have a computers. Yeah. And most of us are here. You must learn it, but we must be prepared with a very good basement because the principle was the same. Yeah, about the DNA, RNA, and so on. And there is new steps. It's only application. It's the speedness or preciseness of the test, but glycolysis was same, and the principle of the signal transductions, receptor. Second messenger going inside the nuclei, change the DNA, mRNA, and go to proteins. And if you will know this very basement and very strong basement, we should apply it and learn whole life for the new items which is going.
Thank you. And another question from Arzu Etem. Dear Professor Zima, thank you for this explanatory presentation. What do you think about the accuracy of measurements made by wearable technologies and their reflections on clinical practice?
Yeah, it's a very good question. The accuracy of the measurements, it's problematic. Not that the equipment will not precise, but if you have the glucose watch or watches which measurement ECG, you should rotate it. As example, as now you put here on the back side and so on. You not maybe strictly put here, and it's a problem for compliance between the patients and the equipment. But this wearable technology is done. We must looking for the data of the patients, and I think it's maybe put the critical results. There is no discussions and no problem if you have a glucose watch and it's measured glucose 4 and you have a 6, or it's measured 3 and you have a 5, or you have a 6 and you have a 8. But it's important if you have if measured and you have a 15 or 20. I think it's important for the risk go out for the risk corridors. Yeah, and this variable technologies will be growing up, and also the plethysmography measurements as I show through the mobile. It will be growing up, and but they need the correctness in the lab and correctness in the physician. But it's maybe the first symptom or first signal to do something, to contact the emergency or contact the physicians, because some of these technologies have the alarm communication with your physicians. Yeah, and it will be growing up. Yeah, I think in near future, it's people like to need some measurement calories, measurement blood, heart rate, something, and the companies is growing up these technologies, and it will be more precise. Yeah, but I think it is the first step. If there is some worse data, no, there is a risky data, directly communication with the physicians or some call center, or go to the physician to confirm the data. I tell you the story. We're discussing about the variable technologies, but we doing 15 years ago the test in your hospital. I recommend you if you're not done, because many companies, many drug companies make sometimes the gift of the glucometers. And in our hospital, we have the glucometers all around the wards, and it's paid the test. And we decided with the management of hospital that we will prepare the system of the glucometers on the wards, which will be connected to the laboratory information system, and which will be guaranteed by our central lab. And the one person testing the glucometers, now we have a system. And we will taking the glucometers from the wards to testing to the lab. 35% we put to the trash. They put the data. If you put the blood, there is something 15 or 8, but it's totally worse because it's not controlled. And it is a problem with the variable technologies or PCR, the POCT or near patient testing equipment, because you receive the data and you are said, okay, I have the number, but nobody precisely testing if this data is true or not true.
Thank you. Another question from Emel Çolak, a young specialist. Dear Professor Zima, I would like to thank you for your instructive and informative presentation. What do you think about direct-to-consumer tests, which have invaded every aspect of laboratory diagnosis recently, including genetic testing? Do you have any legal regulations in Czech Republic?
Thank you for a very good question. This test, which is growing up because it's very good business, but without any trueness. Yeah, it's growing up, and what we should do, it is educate the society with some application as a lab test of online or some campaign, because this testing, it's only the waste money. We have some techniques which putting the data to patients, 200 parameters measured by some crazy electronic generator of the numbers, some sending the hair, sending the blood, sending something. Yeah, it is only to educate society, because this is many people putting to the market. We have no regulation on it if it's not said that it's a medical device. If it's not said, this make a diagnostic process, and it's if there is a legal regulation. But if I put to the box and I said this test should mention that you are pregnant and will be water and yellow water, it's possible. It's only if you go to the curve, it will be have some penalty. But this company, it changed the owners and changed the name. We have one story a few years ago. And there was a 10 equipments which make a data or laboratory data, which only generated the numbers and looking. We testing with a state institution, and we put the obese lady. And the generator said, you have a high cholesterol and normal glucose. This lady had the normal cholesterol and high glucose. We have the patient with the hematology malignancy, but looks very well. And your blood count is normal by this crazy measurements. But you have a 30,000 leukocytes. Yeah. But finally, the state should go with each providers of this 30 equipments, the CURT process, because it's every owner is different and it's very complicated. Education on this thing, and it is war which we not should win because the people believe something. If the people believe that Earth is flattening, what we will do was this nice test with nice pictures to helping you that you will be healthy and living to the 100 years.
Thank you. Another question from Bilgen Özdemir, a senior specialist colleague. Do you think that laboratories take responsibility for patient safety?
Definitely yes. In the area of the laboratory, yeah, we take care of the patient safety for all kinds. What is in the sampling center? What is it? As I mentioned, also the ethical issue. If you will taking the 10 tubes and I need only the 5 tubes, it is non-ethical and it's out of patient safety. Yeah, we have the responsibility on the patient safety on our area.
Thank you. Another question from our treasurer, Professor Mehmet Şeneş. Dear Professor Zima, thank you very much for your presentation. What do you think about the future of the laboratory medicine education? A similar question.
I think on the universities, the education, it's widely spread and many models in different countries in Europe. But there will be the different fields on the non-medical schools, faculties, which will be preparing the expert for laboratory medicine. I know some programs in our country are also in abroad. There is a widespread knowledge about the biochemistry, genetics, microbiology, and immunology. In MDs, it will be clear we should implement it 1-2 weeks in the curricula about the laboratory medicine. We have this 1 week on our medical school. It's 1 week, 25 hours. It is a seminars which go through whole laboratory medicine. It's after the basic knowledge of the biochemistry, immunology, microbiology, etc. But there is a laboratory medicine view for a 1 week. No, in the lab is only the visiting, yes, for 1 hour. And for the specialization, I think that it's in the future will be more put together. Yeah, but it will be waiting few decades. But for non-MDs, I think it will be earlier, and now it's done in many countries that non-MD, it is a specialist in laboratory medicine generally, and maybe some specific areas is to be expert in coagulation or autoimmunity or something as a second level. But for a non-MDs, it's very more simple. For a clinical medicine, it is in UMS in Brussels, it is a biomedical specialist, but it's subdivided to the different medical disciplines because some physicians have also the clinical practice, and I don't not see that you will be the geneticians, immunologists, hematologists together with the same with a widespread clinical practice.
Thank you. There are 3 more questions. You are tight, but Thomas?
No, but it's
okay,
okay, perfect.
okay.
I am trained for the students for a half a day. It's it's not a problem for me. Yeah.
Thank you. From Fatma Demet Arslan, from Izmir, a young professor colleague. Thank you for your presentation. What do you think about laboratory specialist training accompanied by developing technologies? How should it be?
Yes, definitely yes. It's if you are in the first part of your specialization, you should go, and it may be implemented in the curriculum or in your experience, to go somewhere for a few days to looking what happens with mass spec or proteomics, yeah, because it's very specific equipment, which in the lab have a 1-2 specialists which doing only proteomics, which doing only mass spec measurement, because it's not so simple. And for your basic knowledge, it should be 1 or few days visiting these labs and make a knowledge what should be done by this equipment. What is a positivity, what was the negativity, what was the accuracy when asking for this technology. I think it's a way for the education is this very new and developing technologies, because this technology not be widely spread. It needs a knowledge when to do it, and if you will be focusing on these technologies, okay, you need a deep knowledge and working on it. It's mostly for the non-MDs, because it's as MD education in the whole world is not focusing for the technological issues. And we mentioned the molecular biology. We have a few lectures, few practical lectures and seminars, but the studies on the Faculty of Science, maybe 5 years studying only the molecular biology. And it's in a non-MD's specialty, and the MDs should know what should be done with this equipment, how will be helpful, and the technologies professional. It needs a specialist. It's not that one day you will do proteomics, or 1 week, and next week you will do the mass spec, and Saturday you will do the NGS. It's unbelievable. It's not done.
Thank you. And a question from Hamit Hakan Alp, Professor Hamit Hakan Alp. First, thank you for this great presentation. What do you think about the current state of proteomics? So far, important proteomic biomarkers have been obtained in a few types of cancer, such as ovarian cancer, but it seems that they are not at the desired level.
It's a very good question. 20-25 years, there was a very enthusiasm that the proteomics will be sorted out. We take samples, proteomic analysis, do the map of the patients, and we said it is disease 1, disease 2, disease 3. Not done. Yeah. I think that proteomic marker is important. I mentioned that we need more knowledge about the biomarkers connecting to the cancers and how it's changed during the treatment. And if the marker is only marker, or you have some not said the preventive, but predictive for the prognosis, and if it's a prognostic marker of the cancer, and it needs the studies, and I believe that it will be done not in the near future, but in the future, that we make a protein map of the tumor, and we said, okay, we will look for these 5 markers every half a year, and if it is going up, going down, it's maybe the worst prognosis or better prognosis.
Thank you. Another question from Professor Taner Özgürtaş. Thank you very much, dear Professor Zima. what is your imagine about laboratories next years? Will we be need laboratory people in our laboratory?
Definitely, yes. We will need the people. We will need the skillful people with widespread knowledge, because the laboratory people is overlapping many disciplines. From the medical part of view, we must communicate with the professionals in nephrology, neurology, cardiology, intensive care units. And we need bioinformatics people because we will working with huge amount of data. We need the analytics professionals which have the principles of the equipment, and definitely we need the laboratory people. What the question? How people in which how professions? It should be that some labs need the technicians, make the non-MD professionals, which is looking for the technical part, and the data should be sent to my computer. I said some examples. In my lab now will be only 2 technicians. I am in Izmir, and the data is going through my. I am not in Prague. There are 1 technicians, 1 non-MD higher educated, which looking that it's all processes done, internal control, external control, processes done. And I'm in Izmir and I'm looking in computer and said, please this repeat, this not repeat, please call. I will call to emergency unit. This is a critical data, and it goes through. And I will now in my computer, I should have 3 labs. 1 in Izmir, 1 from Prague, and 1 from Heidelberg. And I'm expert in biochemistry. It's done mostly in the imaging. In imaging in India, there are the centers which make the reports for magnetic resonance, for CT scans, and so on, all around the world. Yeah. And it's a question if all professions will be in each lab. Maybe, okay, the biochemistry is widespread, but the expert of the coagulopathies, it should be 1 for 5-10 million people, and sitting in computer and consulting and approve the pathological data and sending comments. And it should be in Taiwan on the beach, 2 hours, half a day on the beach and half a day in the computer, and sorted the data and comment the data for a different hospital and different laboratory. It's maybe in the future, but people is definitely needed. We make some automated approving system in the laboratory information system, but people is needed.
Thank you. Another question, 2 more questions. Dr. Zima, thank you very much for your great talk. Proteomics, metabolomics, etc. studies require huge budget, time, large number of researchers, and collaborations. How can laboratory medicine progress in this regard?
Yes, you are fully true. This it's need a budget for equipment, need a budget for the daily based, but needs a very skillful and very expert person. And this center of proteomics, metabolomics, etc., it will be few in the country, which will be some centers for Turkey, Czech Republic, and so on. And it should be economically done. I not believe that these technologies will be in every big university hospital. I think it's 2-3 centers in the country. Okay, in Turkey is a big one, yeah, maybe the 5-10. But it's need the effectiveness of the process, and you need a very skillful researchers or scientists which will work with this equipment. Yeah, it's not be that in Izmir will be 5 proteomic labs in the hospital and 2 metabolomics labs in hospital. It's not effective. We have also no people. Finally, you have the money, but if you have the proteomics equipment and you need skillful staff, it's nothing. Need very qualified people.
Thank you. The last question from Professor Levent Kenar. Thanks for the very fruitful talk. As you know, artificial intelligence systems are open to be widely used in medical lab science. Some would be algorithms that identify health problems based on patient lab samples and compare them with thousands of other samples in an artificial intelligence database.
It's very great question. Yeah, I think
please,
that it's
please continuing the question. What is your view about the topic that it would be used to speed up the workflow and to advance the systems testing more samples in a shorter period of time and provide highly accurate results, at least to reduce the risk of medical errors? Thanks for your highlight. Please.
Yeah, there are maybe two parts. Yeah, one part using the artificial intelligence. I think that is a expert system will be growing up, which will be take all data from imaging, from the labs, and make some widespread view for the patient. And it will be helpful mostly for the imaging, and also in the labs. And it's comparing this data and put some diagnosis and looking for prognosis. Also the data from genetic, because it should be in future that the people will be make a sequencing of the genome, put this profile and working on it. And I think that at the time, the artificial intelligence not so speed the workflow in the lab. I think it should be speed by very good equipment with the very good throughput of the tests and effectiveness of the laboratory information system. Because we not mentioned that artificial intelligence, but in laboratory information system, you put, and we said maybe the automatic control. If the data is inside the reference range and not change by 2 or 3 delta between the last sampling or last test, it's automatically approved. Yeah, and it's also the artificial intelligence. It's done by us, but it's maybe save time when we're looking for the complicated patient. And it will be make a shortage of period. This automated approving in laboratory information system. And I think that it's not maybe the accurate results. It's maybe the more accurate reports, because the results, I think, if we will have the internal quality control system well established, it's artificial intelligence will be so helpful. Okay, maybe automatically inform us, please, there is an error or something, but I think it's done without. It's maybe save the time, but finally, of course, reduce the risk. But if we will use effectively, because as I mentioned through my lecture, it's be risky, because artificial intelligence it's need. Sorry, I go for electricity.
Saate yaklaştı arkadaşlar.
Okay, I believe that my battery is full, but it's not done. Now it's okay. I am in electricity. But it's artificial intelligence is calculated with a percentage of the disease or something, yeah. But each person is unique. Yeah, it should be helpful, but we not must believe that all will be sorted out. And medical errors, the errors, maybe some mistakes, and which should be done if you checking the 200 results per 1-2 hours, you should missing some pathological data. Yeah? But the second step, it is the physician when you're looking for the patient.
Thank you, Thomas. This was the last question, and there are many thanks. Thank you again for this fruitful presentation, and thank you for accepting our invitation to BCLF and TBS Congress in October. Thank you very much.
Thank you.
Okay. Good evening.
Thank you, Dogan, and thank you, friends, to discussing together. Enjoy the evening, and somebody we should meet in a World Lab in Dubai, and definitely we will meet in end of October in your National Congress or in other area. And thank you very much for a kind invitation. Thank you.
Thank you.
Dogan,
Okay.
good night. Thank
Good
you.
evening.
Bye.
Good night.
Bye.
Thank you.